Hello and welcome to 1.4 Time Value Money, y'all. Anyway, here's the situation. This is basically the most important math lesson you'll ever have. This is life. Here we go. You can either stay in your current mortgage or you can refinance. What should you do? How much money do you need for retirement? For your student loans, you can either pay back the amount in 15 years or you can pay back in 10 years. What should you do? This is all extremely relevant content for life in general. So if we're in class, we would stop and discuss the factors. What goes into this? Like for number one, what would you have to consider if you want to refinance? And by refinance means starting over, starting your loan over, basically, is kind of what that means. So sometimes it actually makes sense to start your loan completely over again, just start over, depending on the rates. Like if your old rate is 4%, but you can start over at 2%, you're going to have to make a decision. Obviously, how much money do you need to put into retirement? So like what kind of interest rate are we looking at that we could get? For your student loans, interest rate is a big thing, but how much can you afford? If you pay it back in 15 years, it's going to be less per month to pay. If you pay it back in 10 years, it's going to be more per month. So there's all sorts of factors that go into this. This equation is the equation that runs the world. It takes all these factors into account. Your monthly payment, your interest rate, the future value, the starting value, present value. So all sorts of stuff in there. And this equation runs every type of loan. It runs depreciation on a car. It runs student loans. It runs mortgages. Everything. It's this equation. And this equation is a beast. And there's been a program, and it's in your calculator, which is why you need a calculator today. If you don't have a calculator, we got to figure this out. Hopefully your calculator is working for you. But if you go to apps, you should see the finance app in there. And then in the finance app is the TVM solver, time value money. And then you get this screen like this. And so today we're going to work through this screen here. So here we go. You have the notes. First you'll see is N. N is the total number of compounds. So what happens in the real world is at the end of every month is when something called compounding happens, and that's when interest gets added, and that could be a good thing. So like interest added to a savings account is a good thing. Interest added to a loan is not a good thing. So when I say compounding, that means that's the moment when interest is added. So added. So for a 30-year mortgage that gets compounded every month, because that's how the world works. Compounding basically happens every month. At the end of the month you make your payment and then a compound happens. So for a 30-year mortgage, compounded monthly, how many compounds would there be? And you can actually just plug that in. So 30 times, you can plug that in your calculator, 30 times 12. You just plug it in, press enter, and you get 360. So that'd be 360 total compounds. So if we were running an analysis of a 30-year mortgage, you would use 360 here. Not 30, but 360. Total number of compounds. I is the interest rate. You don't got to be fancy. You just put it as the number, not the 0.05. So 5%, you're not going to plug in 0.05. You're going to plug in 5. Present value, or the beginning value. So that would be like your loan amount. That would be your present value. How much do you owe on your loan? It could be how much money you currently have in savings, like your current amount or the starting amount, that sort of thing. It's like the starting amount of whatever you're working with. The payment or contributions. So maybe for like a savings, you put in $100 a month. That would be like where you'd put that. You put that right there. Or maybe you have money in the bank and you take out money every month. That'd be like retirement. That's what retirement is. Retirement, you have this big chunk of change in the bank, and then that pays you every month. So it'd be like a payment. So you're either paying into this, or it's paying you. Future value. That's like the goal. So we were planning retirement. It's like that's what we're looking for. What is the future value of my savings? If I start with X and I put in Y every month, what's the future value of this in 30 years or say? So if we're paying off a loan, the future value we want to be 0. We want to pay that loan down until it's 0. So if we're looking at loans, it's 0. Payments per year, that just depends on the problem. Now in the real world, this is always 12. You always pay every month. Payments per year. Compounds per year, again in the real world, it's always 12. So you'll always see that as 12 and 12 for the most part, unless the problem specifies a different type of payment and compound. So you just got to read carefully in the question. If it doesn't say, you can assume 12. So like on your first problem on your homework, you can just assume compounds are 12 times per year. And then there's other things like a fortnight. You pay every fortnight, which is 26 times per year. So you'd have to pay 26 times per year, change these to 26, which is it's just complicated. But that's what the IB does sometimes. All right, now there is a bit of a picky little situation here, and that is, like if you look here on my calculator, present value is positive and payment is negative. So there's this kind of like little picky dance here you got to work with the positives and the negatives. And so I think that I broke it down for you here. The present value, the payment, and the future value can be positive or negative depending on the situation. Okay, so think of it as if the money's in your pocket, that's a good thing, it's positive, we like that. If the money's in the bank, it's negative. And that's pretty much what I'm saying here. And you'll see as we go through, so pause the video and just read through these. Typically one will be positive and the other will be negative. So like here, in this example that I had in my calculator, this would be like paying down a loan. We started with $23,000 and we ended at $0. And notice that that's positive and my payments are negative. So there's more than likely going to be a positive and there's more than likely going to be a negative involved in these problems. So there you have it. Now we're going to do some examples, and the idea is that you catch on as we run through these examples. All right, so you want to start a savings account. You find a savings account that will earn you 7% per annum. You might see that as PA. That means per annum. You'll see that on your homework. And that's pretty reasonable in the long run to get 7%, even like up to 10%, depending on how you invest. So 7% per annum, that means we're working with a 7% interest rate, compounded monthly, on your investment if you keep your money in the account for at least 20 years. So that's typically what happens. You're going to get a nice rate as long as you keep it in for a certain amount of time. So how much money will you have if you invest $10,000 for 20 years? So what that means is, here's what we're going to plug into these values. So we're going to invest for 20 years compounded monthly. So how many total compounds? You can go and just plug in 20 times 12 for that value right there. So plug in 20 times 12. in your calculator. So 240. That should show up as 240. Interest rate is 7%. So we're just going to keep that as 7. Plug that in as 7. Present value. You have $10,000 to invest or to put into, this is called actually an annuity. So the question is that going to be, are we going to plug that in our calculator as positive or negative? Since we are putting it into the bank, we're going to call that negative, but it's going into the bank. You're going to invest $10,000 and it's sitting in the bank now. In this situation, you're just plugging in $10,000 and you're just letting it sit there and grow. So you're actually not making any payments towards that $10,000. The future value is what we're trying to figure out. What is this $10,000 going to grow to if we invest it for 20 years, for 240 compounds? Payments per year, 12. Compounds per year, 12. Even though we're not making any payments, just keep these similar for the most part. I think, you know what, I think you could change that to 0 actually. Hold on. Just keep it at 12 for the moment. Give me 1 second. I'm plugging this into my calculator as well. So 247, 10,000 in the bank currently. 0 payments. Let's see if we can change this to a 0. Nope, it won't let me. It won't let me change that to a 0. Because here's why. Technically the bank is paying you interest, so you need to keep these the same for now, unless something crazy happens. But so here we are. So we want to go find the future value of this. So you highlight future value, and then you press alpha. That'll get you to the green, and then you press solve. So there it is. There's your future value. Your $10,000 in the bank becomes $40,000 in your pocket, which is why it's positive. Negative in the bank, positive for that. Okay, so the future value ended up being $40,387. That was the answer to that. Okay, now we're going to keep going. How much will you have if you invest $10,000 for 40 years? So now all we have to do is go up here and change this to a different number of compounds. It's going to double the amount of compounds. So you plug 40 times 12 now. There it is, 480 compounds. And now change your future, go down to your future value and press alpha, solve. That turns it into 163,000. Interesting. $163,114.11. And that was 480, 7, 10,000, 0, 12, and 12. Interesting. That's quite a bit more. Even though that's more than double, you doubled the amount of years, but that's almost 4 times as much money, which is pretty awesome. Because you're earning interest on top of interest. The more it's in the bank, you're earning interest, and then the next year you're earning interest on top of the interest, and then on the next year you're earning interest on top of the interest. It just grows. It grows exponentially. It grows geometrically, which is why this is following the geometric sequence lesson. How much money will you have if you invest $60 a month for 40 years? So let's talk about this. So now we're dealing with 40 years, so it's the same. We can keep this the same. So the number of compounds is 480. Interest rate, we're going to keep as 7. Present value. So if you're not plugging in a lump sum in this scenario, so you're actually starting with 0. You're starting with $0 in the bank, and you're putting in $60 every month. Because you're putting it into the bank, it's going from your pocket into the bank, we're going to call this negative 60. Future value is what we're going to solve for. Keep that as 12, keep that as 12. Okay, so now plug this in. 7, future value, present values, that. We're going to do negative 60 for that. And we're going to solve for future value. 157,488. That's what $60 a month turns into for 40 years. It's almost the same as 10,000 for 40 years. So these are very similar as far as that much money goes. For D, suppose you want to have $1 million. That's our goal. We want to have $1 million in our pocket at the end of our retirement, or when it's time to retire. How much do you need to save each month if you want to retire in 40 years? So here's the deal. We're still dealing with 40 years. We still have 480 compounds. That's 40 times 12. Interest rate is 7. The present value we're going to put as 0, because I'm going to say if I start at 0 and I end up with $1 million, how much do I need to put away each month? So the payment is the question. How much do I need to pay into this? Our future value is going to be $1 million, and I want that positive because I want that in my pocket. And it doesn't really matter, actually. You could have that negative. It would just, payment would be positive or negative, just depending. This is 12. This is 12. Okay. So now let's go plug it in. I want $1 million in my pocket. So you change the future value to $1 million, and then you go and solve for the payment. 380. Let's call it 381 just to be safe. $380.98. That's how much you'd have to plug into the bank each month for 40 years for that to turn into $1 million. What if I change this to what if I change this to negative $1 million? So that means we still got $1 million in the bank. We go and solve for this. That just makes it positive. Okay, so basically, if this one's negative, this is going to turn out to be positive and so forth. So there's a little bit of leniency there. You just gotta be a little careful though. Suppose you want to have $1 million saved up to retire. How much do you need to save each month if you want to retire in 20 years? So that goes back to 240 compounds, 20 times 12. Present value is 0. I want to end with $1 million in my pocket. So we're just going to change the number of years to, we're going to go up and put 240. Present value, $1 million. I want to know what my payment is. So, and you can't leave it blank. So you gotta, I just put like a 0 there, and then I fixed everything else. So my payment now, alpha solve, is $1,900 a month. Oh yeah, by the way, let me fix that to be consistent. Negative $1,900. I got to plug that much into the bank. So that was $1966. That's how much I got to plug into the bank. So look at the difference. Even though 40 is double the amount of years as 20, the amount I got to put in for 20 years is way more than double the amount. And again, it's that interest is being earned on top of interest, which is being earned on top of interest on top of interest.